Okay, so to get the process going, we want the entering variable, and we don't know how to do this on the graph, so we're going to start with the LP model, LP formulation, and then we'll take it up from there. So let's do the primal LP. It'll be minimize 900 F1 F1 W1 plus 400 F1 DC plus 200 F1 F2 plus 300 F2 DC plus 100 DC W2 plus 200 W2 W1 plus 300 W1 W2. Subject to the nodal constraints, which are that F1 W1 plus F1 DC plus F1 F2 has to be equal to 50. Make sure this stays within the bounds here. And next is for F2, it's minus F1 F2 plus F2 DC is equal to 0. And that covers the F2. Now we get to the DC. It's minus F1 DC minus F2 DC is equal plus DC W2. Sorry. Has to be equal to 0. I made a mistake here. This has to be equal to 40 for F2. But DC balance is 0. There is no injection nor withdrawal. Next thing is we're looking at W1, let's say. So we're going to have minus F1 W1 minus W2 W1 plus W1 W2 has to be equal to minus 30. And then finally, for the last node, W2, we're going to have DC W2 minus DC W2 minus W1 W2 plus W2 W1 is equal to minus 60. The other stipulation is that there will be bounds on we have some upper bounds. Of course, everything is non-negative. All variables are non-negative. But question is, should we include the bounds on the flow on F1 F2, which is a bound of 10, and of DC W2, which is a bound of 80? And what we're going to see, what we're going to do is we're going to we'll handle bounds separately. Like we suggested earlier, we gave some idea. in terms of the definition of basic and non-basic variables, will handle bounds separately, not as explicit constraints, not as constraints, not the normal way. Okay, and that's why I gave a little bit of introduction before. Okay, so we have the primal LP, and from the primal LP we can deduce the dual.